So here we have a problem where 7 coins tossed 128 times and number of heads were observed. So out of this 128 times when they tossed 7 coins, so each time how many heads appeared? So 0 had appeared, that is all tails appeared for 7 times, and only 1 head appeared for 7 times. Like that, remaining number of heads, so that is 7 heads appeared for only 3 times. So this is the observed frequency distribution. Now we have to fit binomial distribution using this observed frequency distribution, and we have to test whether binomial distribution is a good fit or not. So for that, first we need to calculate what here? Mean, arithmetic mean. So mean is equal to NP of a binomial distribution. So for a binomial distribution, mean NP is equal to x bar, that is equal to summation fx divided by n. So first we need to calculate what here? Fx column, 7 into 0, 0, 7 into 1, 7, 21 into 2, 42, 30 into 3, 90, 26 into 4, 104, 20 into 5, 100, 14 into 6, 84, 7 into 3, 21. Can you tell me the total? 448. So it is 448 divided by 128. So x bar is equal to, that is NP is equal to, x bar is equal to 448 divided by 128, 3.5. So 3.5 is NP. Okay, so N is 7 here. 7 coins were tossed for 128 times. So 128 is capital N. 7 is small n. So here N is equal to 7. So NP is equal to 3.5. Therefore P is equal to 3.5 divided by 7. So P is equal to 0.5. Is P 0.5? Yeah, right. So P is 0.5. Now we need to calculate what? Theoretical frequencies. So how to calculate them? So first Tx. So here in the theoretical distribution chapter we use Tx, theoretical frequencies. So here as we are using the word expected frequencies, Ex. So instead of Tx we'll take here Ex. So E of x is equal to first probability term n into P of x. So E of 0 is equal to n into P of 0. So P of 0, what is, how to calculate here? P of 0. So P of 0, P of x is equal to NCx into P raised to x into Q raised to n minus x. So since here P value is 0.5, we get here NCx into half raised to x. Sorry, half raised to n. Is it? As P we have 0.5. Okay, so here 7C0 into 0.5 raised to 7. How much? 7C0 is 1. What is the value of 0.5 raised to 7? So this is 1 into 0.0078 is 0.0078. Now first frequency as n into P of 0. So E of 0 is equal to 128 into 0.0078. So how much we get here? 128 into 0.0078. Zero point 9984. So here approximately I write 1 rounded value. So here next recurrence relation, E of x is equal to n minus x plus 1 divided by x factorial into p divided by q into E of x minus 1. N minus x plus 1 divided by x into p divided by q into E of x minus 1. So here p divided by q, that is 0.5 divided by 0.5, that is 1. Is it? So p divided by q is equal to 0.5 divided by 0.5, that is equal to 1. That value is fixed. Just we need to go on filling remaining value. So first E of 1 is equal to 7 minus 1 plus 1 divided by 1 into, so there is no meaning in multiplying 1 here, still write 1, and here 0.9984. So what is the answer here? 7 minus 1 6, 6 plus 1 7, 7 divided by 1 is 7 again, and 7 into 1 is 7, 7 into 0.9984, 6. 7 into 0.9984. 6.9984. Okay, approximately here 7. Next, E of 2 is equal to 7 minus 2 plus 1 divided by 2 into 1 into 6.9984 is equal to. So here 7 minus 2 is 5. 5 plus 1 6. 6 divided by 2 is 3. 3 into 1 3. 3 into 6.9984. 3 into 6.9984. $20.9952. 20.9952. So approximately right here 21. Then E of 3 is equal to 7 minus 3 plus 1 divided by 3 into 1 into 20.9952. So 7 minus 3 is 4. 4 plus 1 5. 5 divided by 3. 5 divided by 3 into 1 into 20.9952. 34.93. 34.93. Next, E of 4 is equal to 7 minus 4 plus 1 divided by 4 into 1 into 34.93. So 7 minus 4, 3, 3 plus 1, 4. 4 divided by 4 is 1. 1 into 34.93 is 34.93. Now next, E of 5 is equal to 7 minus 5 plus 1 divided by 5 into 1 into 34.93. So 7 minus 5 is 2. 2 plus 1 3. 3 divided by 5 into 34.93. Do we get the same? 20.9952. $20.95. Okay, 20.95. As we have taken 2 digits here, we get different answer. Next, E of 6 is equal to 7 minus 6 plus 1 divided by 6 into 1 into 20.95. So 7 minus 6 is 1, 1 plus 1 2, 2 divided by 3. 2 divided by 3 into 20.95. I think 6.99, 6.98. Okay, and finally E of 7 is equal to 7 minus 7 plus 1 divided by 7 into 1 into 6.98. So 7 minus 7 0, 0 plus 1, 1 divided by 7. So into 6.98, that is 6.98 divided by 7. We get 0.99 something. 6.98 divided by 7. Few minutes. 0.9971. 0.9971. So I'll write them here. 20.99, 21, 34.93, 35, again 35, then here 20.95, 21, 6.98, 7, 0.99 is 1. So now the total of the frequency column, expected frequency 7 plus 1, 8 plus 1, 9, 9 plus 10, 19 plus 1, 20, 27, 28, 8 carried to 2 plus 2, 4, 4 plus 2, 6, 6 plus 6, 12, 128. So observed frequency total is 128, and now our expected frequency total is also 128. That means our calculations are correct here. Now remember one thing, all the time we don't get such figures here, such a total. Your total based on rounding up the values and how many digits you are taking here. Make sure that you are using 4 digits after decimal point so that you will get right answer. Somewhere don't take 2 digits until and unless you get exactly 2 digits in the calculator. Okay, and whenever you get more than here 1 or 2, frequency will be more or less. You don't get exactly 128 all the time. Here, because of p value is 0.5, we are getting exactly 128. Otherwise, we will not get exactly total of observed frequency here. So that time, you increase or decrease depending on the number here after decimal point. You decide which one to increase or which one to reduce to make the total equal to observed frequency column. Now, null hypothesis. So what is null hypothesis here? We have prepared a binomial distribution. So we assume that here binomial distribution is a good fit for this distribution. So write the same here. H0 binomial distribution. Binomial distribution is a good fit. Then H1 we write binomial distribution. Binomial distribution is not a good fit. Not a good fit. So test under H0. Test statistic under H0. So chi square is equal to summation of O minus E whole square divided by E. So here observed frequency and expected frequency O E. So observed frequency are 7, 21, 30, 26, 20, 14, 3. Expected frequency 1, 7, 21, 35, 21, 7 and 1. So here now we need to calculate O minus E whole square, then O minus E square divided by E. So here expected frequency should be more than 5. So first frequency here is 1 and last frequency is 1. Both are less than 5. So merge them with adjacent frequencies. So this 1 add to next frequency. So both will become 8, and meanwhile do the same with the observed frequencies. So here 7 plus 7, 14. So last frequency is 1 less than 5. So merge this with the previous one. So 7 plus 1, 8, and here 14 plus 3, 17. This step is very important. Most of the time you forget it, so you will lose the marks there. Okay, so now once again 14 minus 8. 14 minus 8 is 6. 6 square is 36. 36 divided by 8. 36 divided by 8. 4.5. Now 21 minus 21, 0, 0, 0. 30 minus 35 minus 5. Minus 5 square is 25. 25 divided by 35. 0.7142. Next, 26 minus 35. 26 minus 35. 9. 9 square 81. 81 divided by 35. 2.3142. Next, 20 minus 21 is 1. 1 square is 1. 1 divided by 21. 1 divided by 21. 0.0. 1 divided by 21. 0.0476. And last here 17 minus 8, that is 9. 9 square is 81. 81 divided by 8. 10.81 divided by 8. 10.125. Okay, now make the total. Make the total. 4.5, be quick. 4.5 plus 0.7142 plus 0.7142 plus 2.3142 2.3142 plus 0.0476 0.0476 plus 10.125 10.125. 17.701. This is what? Summation of O minus E square divided by E. Okay, this is our answer. Okay, now at what percent level of significance here the question is asked? So here the total of summation O minus E square divided by E is 17.701. Now we have to test taking the critical value, and at 5% level of significance testing this goodness of it is given in the problem. So at 5% level of significance, what is the critical value? So to find the critical value here, we need to remember one thing, that it takes n minus c degrees of freedom. What is n here? So in calculation of mean and finding the p value, we have taken n is 7, but here n is not 7, because here we made certain adjustment. So wherever expected frequency, if it is less than 5, we are making adjustment with the adjacent frequencies. So here two cases we have added. First frequency is 1, we added with the next frequency, and the last frequency is 1, we added with the previous frequency. So totally how many frequencies are there here now? That is 1, 2, 3, 4, 5, 6. 6 frequencies you have, means 6 random variables we have. That means n is 6. N is 6. Then what is C? C is how many adjustment we made in the problem. So here one adjustment we made, we added 1 to next frequency, and here 1 added to previous frequency. So we made 2 adjustments. So C is 2. So n minus C, that is 6 minus 2, that is 4 degrees of freedom. So always it is goodness of fit test is upper tail test. So here K2 value we get at 5% level of significance with 4 degrees of freedom. K2 value is 9.49, and our answer is 17.701. In the diagram here critical value, chi-square value lies in the critical region. Since it is greater than K2 value 9.49, so H0 is rejected. That means the conclusion is the binomial distribution is not a good fit for the given distribution. So final conclusion is binomial distribution is not a good fit.